Hi there, we're going to go over 6.4 functions review. Function is a relation in which each value of the independent variable is associated with exactly one value of the dependent variable. What we mean by that is that one given x value must only give us one y value. If a relation gives us If we input one x value, but it gives us two y values, then it's not a function. Function notation, we write it this way. F with x in the bracket, and we read it as f of x. This is a function in terms of x. For example, f of x equals x plus 2, and notice that this is function, so x is what the function is in terms of. Therefore, you can say if x equals 1, then f of 1 equals, we sub in 1 into x, so it's 1 plus 2 here. So f of 1 equals 3. So let's take a look at vertical line test. So a vertical line test allows us to determine if a relation is a function. So for example, if we were to have four grids like this, and the first graph looks like this here, a straight line. Second one's a parabola. And the third one is a sideways parabola here. And the last one would be a circle. Essentially what we're doing here is putting a vertical line on each relation here and see how many intersections we find each case. So when I put that vertical line through the relation here, I only see one intersection. How about here? I still see just one. How about here? I only see one intersection. So this means this is a function. It passed the vertical line test, therefore it is a function. Let's take a look at the second example. If I were to put a vertical line through here, then there's one intersection here. If I were to choose another vertical line to be around here, I only see one intersection. Therefore, this is also a function. Third case, if we were to put a vertical line, I will see two intersections here. This means it is not a function. One exception here will be when the vertical line is put at the end, right here, at the origin. But just because it passed one test doesn't mean it's a function. You need to make sure the entire relation actually satisfies this condition. We cannot have more than one y value for each x value. Same thing over here. If I were to put a vertical line through here, we'll get two intersections here. And again, same idea. If I were to have a vertical line test at the end here that it barely touches the circle, we'll definitely get one intersection. But just because there's one case that only gives us one y value doesn't mean this is a function. So you do have to check multiple times. Let's take a look at example 1. For each of the following functions, complete the table of values and draw the graph. What we need to know first here is that this notation, f of x, is essentially exactly same as y. So we can rewrite it as y equals x plus 4. we want to get used to using two different notations now. So make sure you recognize f of x is not f times x. Okay, so f stands for function. I'll give you the list of x values here, -2 to 2. And we're going to plug it into f of x. So f of -2 equals -2 plus 4. So the first value would be 2. So when x is -2, y is 2. When x is -1, y is 3. When x is 0, f of 0 is 0 plus 4, which is 4. So we're going to stop right there. We're going to continue the pattern and notice how each step will go up consistently. If we go up by 1 in x value, we go up by 1 for y value as well. So we're going to continue the pattern here, and we'll know the next y value will be 5 and then 6. Let's try graphing now. So x value goes horizontally and the y values go vertically. We're going to start with the left-hand side, so -2. So let's actually format this so we can actually draw a little more, balanced graph here. So x value is -1 here and -2 here. So I'm going to stretch it up a little bit. And 1 and then 2. For y, I'm just going to leave it alone because those values are pretty high. So I'm going to use it all there. Okay, so at x equals to -2, y is 2. So x equals -2, y is 2. And then when x equals -1, y is 3. And then when x is 0, y is 4, and so on. We can continue the pattern. And notice this is going to be a straight line. Oh. Yeah, that's good. With the arrows on the side here, because this will continue on and on. Moving on to part B, f of x equals 3x minus 4. So this time we're going to use the same x values here as well. So -2 all the way up to 2. F of -2 equals, notice that we have a coefficient in front of x now, so we do need to include that. So 3 times -2, and the rest follows, minus 4. So we get -6 minus 4, which is -10. And then f of -1 equals 3 times -1 minus 4, which equals to -7. And I'm not going to sub in anymore because I know that this goes up by 3 because of this coefficient here. So we're going to go up by 3 every time we add 1 to x. So we can say that y at x equals 0 is -4, and then -1, and then 2. Let's check these values by graphing. And again, x value here, y values here. I'm gonna stretch this graph as well, just like the previous one. So there you go. And this time I want to make sure my y value go up by 2 or go down by 2. Because our graph actually will have to go up to -10, so I want to make sure that our graph shows everything. So when x equals -2, y is -10, which should be here. And when x is -1, y is -7, so it's going to be in between here, little after -6, little below -6, and then x equals 0 is -4 right here. And then this pattern continues, so add 1, -1 right here, and then 2, 2 right here. And we can actually connect these points to us as a straight line with the arrows on both ends. Now let's take a look at example 2. For each function, calculate f of 3. So all we have to do here is plug in 3 into x. So let's take a look here. F of 3 equals, we're subbing in the x, just like this. This, just like how x is in both cases here. All we have to do is now solve using order operation. So you always do the multiplication first, so it's -9, and you bring down the rest. This equals to -16. Same idea for part B. F of 3 equals 3 squared minus 2. Bad math order, exponent first. So 3 squared is 9. We minus 2, so we get 7. Part C, when f of x equals 5/3x plus 2, and we want to find f of 3, we just plug in the x. Notice that we can cancel the 3's out, and we have 5 plus 2, so f of 3 equals 7. Part D, f of 3 equals 3 minus 1 squared, and we solve the inside the bracket first, so 3 minus 1 is 2, and it's 2 squared, so it is just 4. So that's it for today. I'll see you guys in the next video.